We have this problem on calculus which involves many concepts like limits, integration, functions, area under the curve, etc. So this is the statement. If limit n tends to infinity, n raised to alpha square into integration from 0 to 1 by n, x raised to x plus alpha square minus 1 dx is equal to f of alpha, and let g of x is equal to 1 by root of 1 minus f of x. Now if the domain of g of x is minus infinity to minus k union k to infinity, and if the area bounded by g of x between x is equal to 2k and x is equal to 3k can be expressed as root of b minus root of a, where a and b are integers, then find a plus b. Now this may seem tough at first, but trust me, if you go step by step, it will be easy and you will be able to solve it. So pause the video here and try it on your own, and I'll come up with a solution. So I hope you try the problem. Now here's my solution. So first of all, I'm seeing that this integral has x raised to x in some kind, which is actually non-integrable. So somehow I'll try to get rid of this integral sign. And one way we can think of getting rid of the integral sign, especially when there is a different function, so the different variable in the limits, is by using Leibniz rule of differentiation. And in the case of limits, differentiation comes when we are using the LH rule. So basically, some way we'll try to use the LH rule in this limit to simplify it more. So for that, we need some kind of fraction like f of x by g of x, where both are in such a form that they either tend to 0 by 0 form or infinity by infinity form. So for that, I've written it like this. The whole integral will be in the numerator, and this n raised to alpha square, I'll write it as 1 by n raised to minus alpha square, so that we can take it in the denominator like this. If we see this integral as n tends to infinity, 1 by n will tend to 0, so the integral will basically become 0 to 0. So the numerator will become 0. So we need even the denominator to tend to 0. And if we see n raised to minus alpha square, which is basically 1 by n raised to alpha square, as n tends to infinity, this will also tend to infinity. So the whole quantity will tend to 0. So we got a 0 by 0 form here. So we can use LH rule. Now, like I said, using the Leibniz rule of differentiation under the integral sign, first we substitute the limit in by replacing x. So 1 by n will replace x in both these places, and we multiply with the derivative of 1 by n. Similarly, we do with 0, but obviously that will be equal to 0, so I'm not showing that. And obviously n raised to minus alpha square we can differentiate using the power rule. So doing all that, we get this. X is replaced by 1 by n, and we multiply the derivative, which is minus 1 by n square. And I'm just cancelling on the negative sign. Now you'll see that n has many powers, like 1 by n raised to all this, 1 by n square, n raised to minus alpha square minus 1. So I will combine all the powers of n to see what all will cancel. So on doing that, you see that everything will cancel except for minus 1 by n. You can try it on your own. So we basically have 1 by alpha square into limit n tends to infinity, n raised to minus 1 by n. Now let this limit be L. Now I'll be evaluating L. So one good way of solving such limits where there's a power is by taking log, so that we can get rid of the power. So we'll do that here. So we get that ln of L is equal to minus limit n tends to infinity ln of n divided by n. Basically it will become ln of n raised to minus 1 by n. We take the power outside, so it will be minus 1 by n into ln of n, which I have written it in this form, taking the minus sign outside. Here also, if you see, ln of n as n tends to infinity will tend to infinity, and obviously n will also tend to infinity, so we got an infinity by infinity form again. So we use LH rule again, and we get this. So limit n tends to infinity 1 by n, which is obviously equal to 0. So we get ln of L is equal to 0, or L is equal to 1. So we got L is equal to 1 here, so f of alpha will be equal to 1 by alpha square. So we got that. Now we need to find g of x, which is 1 by root of 1 minus f of x. So we'll substitute f of x as 1 by x square to get this. Taking the LCM, we get this, and root of x square, as you know, will be mod of x. So we'll substitute that as well to get g of x equal to mod of x divided by root of x square minus 1. Now I think you can clearly see that this value in the denominator must be greater than 0, because first of all the value in under root should be greater than or equal to 0, and since it's the denominator, it can't be equal to 0 either. So we have x square minus 1 greater than 0. From this we can clearly see that the domain will be minus infinity to minus 1 union 1 to infinity. So k is equal to 1. And we need the area from x is equal to 2k to 3k, which is now 2 to 3. So the graph will approximately look like this. As x tends to 1, the function will tend to infinity. So from infinity it will come down. So we have this area, and since there is a mod and there's a square root, we don't have to worry about any negative values like the graph going under the x-axis. So we have just the normal integration of x by root of x square minus 1. Since we are dealing with positive values, I have removed the mod and replaced it with just x. Now, uh, now I think you can clearly see that this can be now you can see that this can be solved easily by taking some substitution for x square minus 1, because if we differentiate x square minus 1, we get 2x dx, and x dx is there in the numerator. So I'll take the substitution: u square is equal to x square minus 1, so that u du is equal to x dx. I've cancelled the 2 from both sides. So we have the substitution for the numerator, and denominator will become u. Since it's positive, we don't need to take mod also. And when x is equal to 2, u square will be equal to 3, so u is equal to root 3. When x is equal to 3, u square will be equal to 8, so u is equal to root 8. So now if you rewrite the integral, this will become u du and this will become u. So basically it cancels out and it's just integral of du, which is u, and limits are from root 8 to root 3. So finally the integral area will be equal to root 8 minus root 3. So the form given in the question was root of b minus root of a. So b is equal to 8 and a is equal to 3. Okay, so it should be 3 and 8, but it doesn't really affect the answer, but it should be 3 and 8. So a plus b will be equal to 11, which is our final answer. So I hope you got the same answer as me, and if you didn't, I hope you understood my solution. If you have any doubts or any suggestions, you can comment down below, and thank you for watching.